Okay, genius. Just welcome back to Network Fate channel. Yesterday we have discussed about how the Vxlan. We just discussed about the overlay of HLD view of high level design of how Vxlan is working. What is the how the packet is transferring like that. So today I'm going to explain in depth of packet flow of Vxlan. Okay. So today I have taken some screenshot from Cisco Live. So to get better understanding, uh, let's start today. So if in traditional way, okay, what traditional switch will does, it will do broadcasting, right? You are aware that it will do only broadcasting. So if we're only using broadcasting, so we by default the MT size would be 1544 like that, right? So if you are allowing only broadcast traffic, like then it is okay. Okay, but in our VXLAN scenario, we are going to use broadcast. Yes, broadcast for this segment. It is L2 segment. These are up to these are L3, right? So we use broadcast one. Second, we use uh, multicast, and we use unicast. If you're adding any devices, right, if you are putting any device, it will generate unknown unicast traffic. Unknown, because if you are putting new devices, yeah, obviously we don't know what is the device IP address, what is belongs to the what VLAN, so it will start to do GR. So first thing first, till this leaf, okay, this is a normal 9K switch, leaf switch, okay. Till this switch, it will do traditional LANing. Like the host will connect to the switch, and when we switch on this server, it will go for MAC LANing. Like this is my MAC, and the port is 1/1, right? I have taken one screenshot for this. If you see here, this is actually how it is learning. It is learning. This is my VLAN. This is my MAC address, and this is my interface. This for 1/15, I have connected this particular host. Now you got it, right? So first, if we do traditional MAC learning, it will put it on the table, MAC table, right? Local MAC table, or you can say local station table, whatever you can say. If you are studying, if you are doing ACI, you will see local station table kind of things in theory. But here we can say it is MAC table. MAC table, we have entry of VLAN 100 and MAC is A, and it is MAC is A, and it is port number is 1/1. Okay, for example, I'm saying that. So after, okay, now host A want to communicate with host B. Okay, the frame will now transfer to this leaf one switch. So leaf one switch will start to look up. Okay, second thing is, first it will do MAC entry by default. Discovery, first is the discovery, it happened. Then it will start to look up, I want to communicate with host B, how I can communicate. Okay, it will see the switch MAC table. It will do not find any matching, right? In Because if it is found any matching, right, if it found like host B, if I want to connect host B, this is my VTAP address. For example, this is 192.168.1.2. This is 192.168.1.1, for example, right? VTAP address. If discovery is already happened via L3 link, via multicast, by using multicast, then the MAC entry will be there. But now we are seeing packet flow, right? So we will go with beginning. Now here you understand the traditional MAC learning, it will keep it on the MAC table first. Okay, MAC table entry. Second thing is, it will do lookup. Yeah, obviously that host B detail is not available on the leaf switches. So what it will does, the leaf will put this frame into the tunnel. right? We are creating tunnel between leaf to leaf, right? So in the tunnel it will like in the tunnel it will put the frame to the tunnel. So whenever whatever traffic we are putting into the tunnel, it will do encapsulation, right? So encapsulation, what it will does, it will keep original that Mac frame, it will keep it inside. Then it will make outer IP, like outer IP is source IP would be my leaf one, destination IP would be okay. Let's go through this diagram. So if you see here, um, see here, let's consider this is leaf one, okay? This is leaf one, this is leaf 3, and this is the leaf 2, okay? Here is the spine is there, okay? Yesterday we discussed, right? Leaf, the spine, we are enabling multicast between this, and it will acting as a Renju point, both spine, okay? I tell you why we are using multicast here, because we this is L3 link, right? Between let me bring the diagram. So this is the diagram, right? These are L2 boundary. It will normally do flood and learning, and this is L3 boundary. So by default, okay, by default L3 do not allow broadcast traffic, that you are aware, right? By default, router do not allow broadcast traffic. To overcome this problem, we are using multicast for discovering and ghost detail, right? Okay. Now if you see this, okay, my leaf one, now local MAC table, it will maintaining what is the MAC, what is the VLAN, and what is the port. Local MAC table is maintaining this connected host detail, right? Now this lookup happened, then it is unable to find the destination server detail. So what it is saying, it will putting to the VTAP tunnel. So VTAP tunnel, how it will make the packet, right? It will say source MAC is my MAC 1, destination MAC I don't know, so I am putting as a multicast, right? This is the multicast. We using multicast. We using some loopback, so it will put that loopback MAC address for Ranju point MAC address, right? Then outer, yeah, source IP would be my VTAP IP, okay? Destination IP I am using multicast group. It is using UDP protocol and it is using VNA ID. This is actually the original frame. It is original frame. But in traditional way, how it does, only this packet will transfer through the network, but here we are putting encapsulation. So we are using Vxlan, and we are using UDP protocol, and we are putting source IP and destination IP for outer packet, and source MAC and destination MAC. Now this tunnel, okay, this tunnel is try to communicate with spine, Ranju point. It will ask, hey, I am the packet, okay? This is my source address, this is my source MAC, this is my source IP. I want to get the detail of the destination MAC B. How I can get it? So the query will go to the multicast Ranju point. So it will what multicast will does, it will check who is my neighbors, like. So when you enabling multicast, when you configuring multicast on the multicast on the NV interface, when you configuring under NV interface, you used to configure what is VLAN, VNA ID, and part of what we MCAST group 2.10.1.1.1, for example. So this VTAP tunnel, it will communicate with the Ranjo point. The Ranjo point will send the query back to blindly the spines which you do not open the packet. It will blindly send the query back to whoever neighbor with me. It will send the packet to the neighbor. So it will go to the VTAP 3 and VTAP 2. So VTAP 2 will both will be open the packet. It will see, okay, I see that your source MAC is this, okay, your source destination MAC you want to be communicate with B, but actually I do not have that packet. So what it will do is it will discard the packet same way. Leaf 3 don't have the MAC address detail of B, so it will simply okay, I don't have detail, I am discarding this packet, right? Then leaf 2 also part of PIM neighbor, like part of multicast group. So it will go to this multicast group, it will open the packet, it will see, okay, you want to communicate with you want to communicate with B, okay, what is the Vxlan ID? Okay, this is Vxlan ID, this is the MAC, and this is my IP, source IP, right? It will open the packet, it will see, okay, I saw this is okay, destination will be what is that, you want to communicate with MAC B, yeah, I am local MAC table, it will check, okay, this is my, I am here, this is my VLAN is 100, my VNA is 10k. It will see, it will reply back to that query, it will say that, hey, I am the MAC. So local destination table, it will maintain the table, right? MAC address table, it will maintain the L2 detail. So it will put it on the L2 read, and it will go to the, if you see this one, let me show that output, so we will get to understand. So local table, it will maintain what VLAN, what is the MAC address, and what is the interface, right? Then it will put it in the L2 read. It will say that, okay, this, if you want to reach this MAC, this is the port. Okay, when it is going via BGP, it will say, if you want to connect this MAC address, it is my part of this VNA ID. I am understanding you are might confused. Let me reclarify. Normal, what it will do, right? MAC learning source. So normally it will say, this is my source MAC A. I want to communicate with the destination MAC is B. So it will look out the local MAC table. I do not have the detail of MAC B. So what it will does, this switch will send broadcast, right? This is actually do flooded learning, right? It will say my destination MAC I don't know, so I am putting, I am replacing, instead of B, I am replacing with FF, right? It will do broadcast. Here, instead of going broadcast, we are using L3 link here, right? Spine to leaf, we are using L3, so we can't use broadcast, so that's why we are using multicast. While I am showing the configuration, it would be very easy, so don't get confused. Here we are using multicast because we can't send out the broadcast through the L3 interface, that's why we are using multicast. Just keep it in mind. So the multicast, this is a procedure to the multicast do neighboring, like that we have to make it is a PIM join. Then it will use IGRP protocol to learn that neighbors details and all. So what it will maintain, right? What the multicast is helping here, multicast is helping us to know about what are the VTAP, what are the switches locally connected device, right? This all MAC address detail, it will kept on the local destination table. So the PIM will exchange their detail to the whatever leaves are participating part of this multicast group. It will exchange their data to each other. So multicast is helping for flood and learning. Actually multicast is using for flood and learning. It is helping actually. So once it is learned, right, so all the leaf, all the VTAP, okay, it will maintain that database. Like if you see here, like, okay, now I receive the packet, okay, I'm replying back to, okay, this is okay, if I can see I received your ARP request, right? I'm replying, how I am replying, I'm replying like this is my source MAC is this leaf 2, right? This is my source MAC, destination MAC I know, this is VTAP 1 MAC, then source IP would be 2.2, this VTAP IP2, and destination IP will be 1.1. I am UDP for encapsulation. and this is the VNA ID I want to communicate, and I'm sending ARP response, right? So the VTAP to VTAP, it will do not work based on the VLAN. It will exchange the data based on Vxlan. The NT will happen based on Vxlan, right? So once the traffic is getting back to this VTAP, right, this tunnel interface, then the switch will process. Okay, I am receiving this via tunnel, right, VTAP. Then I will decapsulate. This is the server. What I do, I will start the decapsulation process. So decapsulation process, what I do, okay, this is what is a Vxlan ID, like VNA ID, okay, 10,000, right? For example, VNA ID is 10,000. What is the matching VLAN? It is 100, right? So when decapsulation, what will happen? It will find out what is the associated VLAN ID, VLAN 100. Then it will say, okay, it is VLAN 100. Okay, what is the VLAN 100? And it will say what is the MAC address, right? It is generated ARP request, so it will have the source MAC. It will check source MAC address. It is in A. Then it will match with the local MAC table. It will say, okay, VLAN 100. Yeah, I do have. MAC address to A. Yes, I do have. This host is connected to my leaf locally. Then which port it is connected? It is connected to 1/10. Then it will deliver the packet to this particular server. Now you understand, right? So traditional way it will go via switch to switch, but here also it is going via switch to switch, but here we using tunnel. So here it is happening encapsulation and decapsulation. There's only difference is only encapsulation, decapsulation happening. Apart from everything is same. Like everything is same means we are using instead of broadcast we are using multicast. One thing. Second thing is VLAN. For VLAN here communication is happening via VNA ID. Instead of VLAN ID we are using VNA ID. Okay, now you got it, right? How the packet is getting encapsulated with the source MAC and destination MAC. What is the source IP and destination? If I do not destination IP, then I will put destination IP will be my multicast IP. Multicast will do multicast job is do flood and learning for initial first time. Once is learning is happen locally, then it will share the detail to all the leaf switches. So the leaf will maintain the database. For example, second time the packet is getting to reaching to this leaf one, right? The leaf one now knows if I want to reach MAC B, right? If I want to reach MAC B, then this is the VNA ID. Okay. If I want to reach directly, I will go for DOTA 2. I will go to VTAP tunnel 2. VTAP 2. How it is no? Because once the discovery is happened, then when our request is coming, it is coming with all the detail, right? It is coming with what is VNAD, what is the IP address, what is VTAP tunnel IP address. So once the synchronization happen, then VTAP will know about all the VTAPs. So second time the packet won't go to the leaf 3. It will go to the leaf 2. Hopefully now you understand how packet flow is happening on the Vxlan, right? Let me show you that output of the already I shown that. This is the Vxlan host learning. If you see here, right, this is the VLAN, this is the VNA ID. So here we use VNA ID. Okay, so under this is the actual tunnel creation command. So under in NVE we are saying this, hey, this is my VNA ID. It is part of this multicast group, right? So this is a data plane running. If it is going for control plane, right? Control plane is we are using control plane is BGP, right? So BGP, what we are saying, host reachability protocol BGP. So the communication is happening type 2, type 5. These are the loop lining type we are seeing on the Vxlan. Type 2 will be MAC detail only. MAC plus IP. Type 5 will be only IP prefix detail. I will show you during lab. Okay. Now we can focus. You understand that why we using multicast, because L3 do not allow broadcast traffic. This is the configuration. Why we are using VNID? Because for Vxlan there is a requirement we have to use VNID. So Vxlan in data center we might use more than like what to say, by 4096 is the maximum ID, right? Vxlan ID. But in data center we can run, if you example, if you are running Google or some Azure data center, right? So there will be VLAN range would be more than 1 million, right? So that's why the VXLAN it have feature of using VNA ID. So VNA almost we can extend up to 6 million, right? Well, we can whatever VLAN we create, we can give the VNA ID up to 6 million to 6, yeah, nearly 6 million VNA ID we can exchange here through the network. It won't get any collision or it won't get any conflict. So that is the purpose we are using VNA ID. And yeah, and I will show you the packet types and all. Let me take a note. Okay, here the packet type. If you see here, when you are sending this is the actual original ARP request, right? We are sending ARP request, right? This is original L2 frame. So here we are putting VXLAN header, this 8 byte. Okay, then outer we are using UDP header, and we are using IP, and we are using outer MAC address. This we already saw that, right? BTAP IP it will taken BTAP IPs. If it is first time learning, it will take source is the BTAP IP and destination will be multicast. Once it is learning is one flood learning is done, then it will take source is VTAP 1, destination is VTAP 2 address details. So this is the fact, if you see here it is mentioned, right? 6 million possible segment we can create. Normal VLAN it will up to support 4096 like that. But if we are running data center, we will use the VLAN beyond this range. So for that we are using Vxlan. Okay, this is a simple thing. There is a other feature also there, but keep in mind the simple thing is we are using Vxlan to for identifier purpose, right? Instead of VLAN we are using VNID. So actually what we are doing, for example, if we are creating VLAN 10, we are putting VNID like any number. Let's put 1000. Then we are using this VNA ID to putting into the tunnel. Okay, only this purpose we are using this. So I hopefully mostly I covered what are the important things is needed, right? So now I tell you technically how the flow is happening, right? If you are using most of the real-time scenario it is leaf, right? So we use server, definitely it have two links, like, so first time the server will generate gr creative arc, right? It will generate gr. So here it will say it will get entry for MAC and port details, everything, MAC table, a normal traditional MAC table. Then this actually it is these two, right? These two we used to configure SVI IP. So we will use the server gateway will be SVI IP. We don't use any physical interface IP. We used to create some SVI IP, and we'll use under some VRF actually. Okay. The first thing is ARP. Second is L2 RIP. Then it will put it in the BGP table, EVPN. So L2 RIP it will put MAC, post MAC plus IP. Like this is actually type 2. You see I told, right, type 2, type 5. Further video we can see when we do lab, we can see that for this by type 2, type 5, this is actually type 2, type 5. So what else I have to cover? Please take a screenshot for this. Actually, you will get to know when the flow is happening. This is actual flow, local learning, then flood map learning, multicast learning, right? This is a uh, uh, what is this particular map? It is having this connected to the service connected to this interface. This table will be there in the local multication table. Then L2 rep have the same table. It will maintain same thing. And when it is putting to the L2 EVP antenna, it will say that if you want to reach out this particular MAC, this is my VNA ID. Just come to me. Then it will go to associate VTAP. It will decapsulate the packet. It will see this is the MAC and this is VLAN. This is the interface. It will deliver the packet to the particular that respective server, right? So overall, this um, I will go through again. Here it is L2. Here we see L3. Underlay we are using OSPF, and we are using multicast for flood and learning, because it will won't allow broadcast, won't allow under L3 interface. Okay, VTAP and VTAP will exchange their database. So if host B want to, if host A try to connect host B, it will look up the localization table like leaf1. Leaf1 knows that if you want to reach the host B, my next hop will be 192.168.1.2. So the packet tunnel directly it will deliver either using either one of link. It is using ECMP. So for example, first packet will go via this link, second packet will go via this link. So it will deliver to this tunnel. This tunnel will do decapsulation. It will strip the packet and it will see, okay, this VNA ID matching VLAN is 100. This then it will check the local MAC table. It will find out what is the interface. Then it will deliver that frame to the interface. Okay, that's all today. Today we mostly covered packet flow, how it is happening. Let's see you on the next video. Thank you. Bye.